Hello and welcome to your 5th pre-algebra class. I am Mr. Marquez, your summer online facilitator, and today we're going to continue to discuss the topic of integers, but today we're going to be focused on subtracting integers. So to kind of review what we did in our last video, we said that adding integers was basically subtracting. So if I had something like -2 plus 5, well, in reality, if I have a negative plus a positive, I'm actually subtracting. So in this case, it would be 5 minus 2, which is 3, and it would stay positive 3 because the 5, which is the larger term of the two, and it's positive. Likewise, if we had two negative numbers like -7 plus -3, our answer would be -10 because in spite of both integers being negative, you just add that normally and pass over the subtraction sign. And of course, if we have two positive integers such as 3 plus 8, our answer was 11 because two positive integers is basically what we've been dealing with pretty much throughout our entire academic careers. Today, however, we're going to talk about subtracting integers. And I have 4 examples, and then at the end of these 4 examples, we are going to go into the practice problems for this video. So, to subtract an integer, there is a rule that for some students can be a little confusing, but if you pay close attention to it, it's quite easy. It says to subtract an integer, add its opposite. Now, what this means is, for example, if I have the exercise 4 minus 10, to add its opposite means that the 4 isn't going to change, or that this is the same thing as saying 4, because the 4 stays the same. Changing the minus sign to a plus sign, and changing the positive 10 to a negative 10. So when the rule says to add the opposite, it's to basically everything to the right of the 4, change it to its opposite. So the minus sign changes into a plus sign, the positive 10 turns into a negative 10, and then you have 4 plus negative 10, which we already know how to subtract, because 4 plus -10 is the same thing as saying 10 minus 4, which is 6. But because the 10 is larger than the 4 and the 10 is negative, we say it's -6. Now, if we have something like 7 minus -5. So 7 minus -5. According to the rule, it states that we're going to add the opposite, which means the 7 doesn't change. When it says add the opposite, basically it's talking about everything that is after the 7, or everything that is happening to the 7. So the 7 doesn't change. The minus sign turns into a plus sign. The -5 turns into a positive 5, and my answer is positive 12. So see, we're adding the opposite, which means adding the opposite of the other number. So the opposite of -5 is positive 5, and the opposite of subtracting is adding. So whenever we're subtracting an integer, we're always going to add the opposite. That means that the minus sign is always going to be turned to a plus sign and the opposite of the number. So if the number is positive 10, like it was in the first example, it turns into -10 because we're adding the opposite. So if we add something like -2 minus -9, the rule says that we're going to add the opposite, which means that everything after the -2 changes. So the -2 doesn't really change, or doesn't change at all. And the minus sign turns into the opposite, which is adding, because when subtracting integers, we're adding the opposite. And the -9 turns into the opposite, which is 9, or positive 9. And that leaves me with -2 plus 9, which we know that whenever we have a positive and a negative, we subtract. So 9 minus 2 is 7. And because 9 is larger than 2 and it has a positive sign, my answer is positive 7. And what about this? What about D? D says 7 minus 12. So 7 minus 12, the same thing applies, okay? Now, you don't always have to do these steps. In fact, the idea of working with integer operations such as adding or subtracting is that you learn how to do it or review it so much that it kind of comes naturally to you. Kind of like when you add two positive numbers or you subtract two positive numbers, that you repeat this so many times that you can just do it without having to do this middle step. But in the meantime, because this may be a new concept to some of you, we do these intermediate steps to kind of explain what's happening and how it's not, how it's not just made up, that there is an explanation to it. So 7 minus 12. we're going to add the opposite of 12. So the 7 stays the same. The minus sign turns into a plus sign. And the opposite of positive 12 is negative 12. So 7 plus negative 12 is actually, and let me actually write this. This is part of the other problem. So let me just box this answer in. Okay, so again, the 7 doesn't change. The minus turns into a plus, and the positive 12 turns into the opposite of positive 12, which is negative 12. And 7 plus negative 12, I subtract, and my final answer is 5, because 12 minus 7 is 5. But since 12 is larger than 7 and it has a negative number or negative sign, we say negative 5. And let me just write that in parentheses here. Okay? So, ladies and gentlemen, again, whenever we're working with or subtracting integers, we're adding the opposite, okay? So in this example here, you guys can see what I did. So 4 minus 10, if I add the opposite of 10, would be 4 plus negative 10, and 4 plus negative 10 is negative 6. The opposite, or 7 minus negative 5, we add the opposite, which is 7, and instead of minus, we'll plus, and instead of negative 5, positive 5 is 7 plus 5 is 12. Negative 2 minus negative 9, again, we continue to add the opposite, so the minus sign turns into a plus. The negative 9 turns into positive 9, and negative 2 plus 9 is positive 7. And finally, 7 minus 12, the opposite of that would be 7, the minus sign turns into a plus sign, and the opposite of positive 12 is negative 12. 7 plus negative 12 is negative 5. So guys, I hope you enjoyed this video. I hope you were able to understand it. If you have any questions, you can always pause, rewind, going to your into the textbook that was facilitated to you, because this is section 1.6 of your review. So we will see you soon, and enjoy the video.